Hey everybody, it's Coach Stoltenberg again, coming to you with the next video in the reactivity unit 13. Today we're just going to take a closer look at these equations for solving for pH, pOH, H plus concentration, and pOH concentration, or I'm sorry, hydroxide concentration. And we're going to work through the sequences of buttons that we're going to use on the calculator, because ultimately really most of this is done by the calculator. So if you know how to use your calculator, these problems shouldn't be that difficult. Let's do a quick review of the equations themselves. So for solving for pH, there's 4 different things we can do here, depending on what the question is actually giving us. 3 of those things are essentially the same thing, but you just have to remember that it's just how the question's wording it depends on which one you're actually doing, but technically it's the same thing. You can take the negative log of the hydronium concentration, or H3O plus, or if they say the H plus concentration essentially is talking about the same thing, so you could take the negative log of that. Or the one that most people forget, or the one that people have this most struggle with, is if they give you the concentration of a strong acid, you can take the negative log of that. Remember, the concentration of a strong acid is essentially the concentration of H plus, because strong acids completely dissociate. So doing those 3 things are essentially all doing the same thing. If you don't like logs and they're giving you pOH, then you can actually solve it for pH a little bit more simply. If you remember, pH plus pOH always equals 14. So if you have one, you can find the other pretty simply by subtracting it from 14. So if I'm solving for pH, 14 minus pOH would give me pH. Okay, that's solving for H plus concentration, or the concentration of hydronium, or the molarity of the acid. It's like the mathematical reverse of negative log. I honestly don't know what to call this. I'm going to say anti-log, but I probably it's probably not correct to call it that. You're going to have to ask your math teacher what it's called. But this is where if we're given the pH and asked to solve for the concentration of the acid or the H plus, this is what we do. We 10 to the negative pH, whatever the pH value is. So 10 to that value, but the key here is making sure we make it negative. Okay, solving for pOH, very similar to solving for H plus, but remember pOH scale is in reference to the hydroxide concentration instead of the hydrogen concentration. So we'll do the same mathematical process, just based off of different concentrations. So it's the negative log of the hydroxide concentration, or again, just like with acids, we can do the negative log of the concentration of a strong base, because of course strong bases completely dissociate. And then the flip side of that other equation, the pH plus pOH equals 14. So again, if you have one, you know the other, just subtract it from 14. So pOH would be 14 minus the pH. And then lastly, solving for hydroxide concentration, or the molarity of the base, again very similar to solving for H plus concentration, we do 10 to the negative pOH. Again, once you know the buttons, what buttons you're supposed to hit, the calculator is doing most of the work. You just got to pay attention to the question. Some of these will be really straightforward. Some of them will be a little bit more complicated. But if you just take your time and read the question carefully, hopefully you'll see that they're not too terribly difficult. All right, so let's go through a couple button pressing sequences here. All right, example 1 says calculate the pH of a solution that has an H plus concentration of 2.3. All right, so we're calculating pH and we have H plus concentration. So what we're going to do is this one right here, negative log of the H plus. Let me get, where's my neat little laser pointer. Yeah, there it is. We're going to do this equation, negative log of H plus. So let's go back. All right, first things first, locate the negative button. Notice this is not the subtract button, it's the negative button. We're going to press it. Then locate the log button. That's the one that spells log, L-O-G, and press it. And then we're going to just punch in the H plus concentration, in this case 2.3. You should have an open parentheses. You don't have to close it at this point. You're done. Just press enter. So we're going to do negative log of 2.3, and you should get negative 0.36, and that's telling you that your solution is really acidic. Well, it should be, because it's pretty concentrated. So let's switch over to my live cam here, and let's go through that button sequencing together. Alright, so my angle's not great, but I think I'll be able to get it. So first things first, I'm going to come down here, hit the negative button. No, not the subtract button, but the negative button. And then let's bring this up a little. Okay, so negative. Then we find the log over here. So negative log, and you have an open parentheses, and that's, now we just punch in the pH, 2.3. And it's still open, but I don't have to close it. I can leave it open. It doesn't make a difference. All I do now, hit enter. There you go. Negative 0.3617, blah, 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 blah. 2 sig figs in our hydrogen concentration, so we only needed 2 sig figs in our pH. There you go, negative 0.36 pH. Very, very, very acidic. Easy, simple simple steps here. The most common mistake I see, by far the most common mistake, is that first little step. Gotta make sure we're hitting that negative button. Alright. Okay, let's switch back over and go look at number 2 now. Second example, this would be the opposite. Alright. Says what is the H plus concentration? So now we're solving for the concentration of H plus, given the solution with a pH of 3.5. So okay, let's go back 2 slides. We're solving for H plus concentration. So this is what we're doing. 10 to the negative pH. 10 to the negative pH. Alright, so let's go back and look at our button pushing. Alright, so we're going to locate the blue second button. It may not be blue on your calculators, it's blue on mine. But find the second button. You're going to hit it. You're going to find the log button again, and you're going to hit it. So notice you're doing the second function of that button. Okay, so you should have a 10 to a little up arrow. Then we're going to hit the negative button. Again, this is the most common mistake I see, is forgetting to do this part, because it's 10 to the negative pH value. So 10 to the negative, then we punch in 3.5, and then hit enter. So our calculator should look something like that first one, 10 to the negative 3.5. You hit enter, and you should get 0.00032. Alright, so let's switch over to our live cam and run through this real quick. Alright, so second, the little up arrow blinking, log. So we got 10 to something. This is the important part to not forget, negative. So 10 to the negative, and it was 3.5, right? Let me double check. Yeah, 3.5 is our pH value. 10 to the negative 3.5, and enter. Oh, the old E. Depending on what your how your calculator's settings are set, but this should be what you get. Remember, this is just scientific notation, so you can write this number like this, but you got to remember that it's represented in scientific notation. So what I would probably do is say 3.2 times 10 to the negative fourth would be my final answer there. Or if I take it out of scientific notation, negative 4 means that decimal gets moved forward 3 times, so 0.00032. Either or right here, both of these answers are correct. The concentration of H plus and hydroxide are going to be really small numbers a lot of the times. Most of the time they're going to be extremely small. So you're going to find yourself with a lot of scientific notation with negative exponents. So I hope you are familiar with how to do those and aren't intimidated by it, because that's how a lot of our concentrations are going to end up being. Really, really small numbers. Alright, let's look at our practice problems. We're just going to go through the 4 problems we have here together, and then we'll be done with this one. Alright, so looking at practice problem number 1, we're on practice problem number 1 in your notes. It says, what is the pH of a 0.09 molar solution of HBr? So we're solving for pH. So solving for pH, right? Let me get this up a little. So we're going to go look at our options. Based on the information given, which one of our options are we going to do? I'm going to give you a second to think about it. Look at your equations for solving for pH. Which one of those ones are we going to do based on the information given? Well, if you think about it, it's giving us the molarity of an acid, and HBr is a strong acid. So what we're going to do is we're going to take the negative log of the concentration of HBr. The negative log of the concentration of a strong acid. Now I know what you might be asking. How do I know if it's a strong acid or a strong base? Well, I gave you a list of them earlier, but I told you I don't expect you to memorize them. That's true, I don't. What you can always assume is that if I give you the molarity of a strong acid or strong base, then, or if I give you the molarity of an acid or base, then it's a strong acid or a strong base. So that's the equation we're using. So now really it's all up to the calculator. So the negative log of that concentration. So negative log, the concentration was 0.09. Open parentheses, so we just hit enter. What we get? 1.045. We had, I'm not going to really worry about sig figs here. I would probably say that this is pH is equal to 1.05. There you go. Stop putting my shadow on the camera. Real easy. As long as you know the equation you're using and the right buttons to press, these are really simple because the calculator is doing a lot of the work. Alright, let's look at problem number 2. It says, what is the pH of a 2.3 liter solution containing 4.5 grams of nitric acid. Whoa, this seems a little complicated. And it is slightly complicated, but it's just asking you to do something you already know how to do. So we're solving for pH, and then I gave you a volume and a mass. So a volume and a mass. Who can think of what we can use to solve, what we can use those numbers to solve for? A volume and a mass. Think about it, think about it, think about it. And you guys are so smart. You got it. We can use that to solve for molarity. So what we have here is we're solving for pH, and then we're given information about an acid. So what we have to do first is solve for the molarity of that acid, then we can use that to calculate the pH. So the equation we're using is the same one we used the last one. Negative log of the concentration of the acid. In this case, our acid is nitric acid. But we don't have that concentration yet. We have to figure it out ourselves. So we need to know what the molarity of that acid is. Alright, well, what's molarity? Moles over liters. We have liters. It's 2.3. Do we have moles? Oh no, we don't have moles. Oh no. So guess what we have to do with that 4.5 grams? You got it. We have to convert. So I'm going to set up my train tracks. 4.5 grams nitric acid, HNO3. We're going to convert it to moles using the molar mass of nitric acid. So grams are here, so grams must be down here. Molar mass, 1 mole per the mass. Alright, so what's the molar mass here? Well, 1 from hydrogen, 14 from nitrogen, so that's 15 from those two. Oxygen 16, 16 times 3, what is that? 16 times 3 is 48. So 48 from the oxygens plus 15, 48 plus 15, 63 grams per mole. If you guys need to use a calculator, please use a calculator to figure that out. Alright, so how many moles do we have here? Well, 4.5 divided by 63. And I'm going to say 0.071. Okay, so that's our number of moles. We can now plug that in up here. 0.071. Alright, now we can use that to figure out our molarity. 0.071 divided by 2.3. And there's our molarity, 0.03. So I'm just going to go ahead and write that down, 0.03. Alright, my whiteboard's not very big, so I'm going to have to remove some of this work. So now that I know my molarity, it's real simple. pH is equal to the negative log of 0.03. So let's plug that in. Negative log 0.03 and enter. We have a pH of 1.52. There is our final answer. So in this problem, it was a little bit more complicated, but again, I'm not asking you to do anything you haven't done before. First thing you had to do was actually figure out what that concentration of that acid was given the information you have. So we had to solve for molarity first, and then use that molarity to solve for pH. But something that you should be capable of doing at this point. Alright, example number 3 here. What is the concentration of hydroxide in a solution with a pH of 9.8? Alright, so we're solving for concentration of hydroxide. Come on, focus. Focus. So we're solving for concentration of hydroxide. So real quick, look at your equations. We're solving for concentration of hydroxide. What do we need to solve for that? If you're looking at your equations, you should only see one. And that equation is hydroxide concentration is equal to the negative pOH. This is the only equation that we have for this, right? We need the pOH. Well, what does this question give us? It gives us the pH. So this is actually going to be a two-step problem. First step is we have to take that given information and find pOH first. But as I said at the beginning of this video, if you know one, you know the other. It's pretty simple. Just subtract it from 14. So the first thing we're going to do is actually solve for pOH. Because we know pOH is equal to 14 minus the pH. So in this case, pOH is 14 minus 9.8. 14 minus 9.8, anybody? Was that 4.2? It's 9.8, right? Let me just double check. Yeah. Alright, it's that simple. We have our pOH now. Now that we have our pOH, we can plug it in up here. So 10 to the negative 4.2. Alright, go to our calculator who's going to do all the work for us. So again, second log, that gives us the little 10, negative button, 4.2. And then just hit enter. 6.31 times 10 to the negative fifth. So our hydroxide concentration (6.31) times 10 to the negative fifth. There you go. So this problem this is one of those problems where we're saying you have to pay attention because it actually gives us the pOH, not the pOH. So if you did 10 to the negative pH, you wouldn't be solving for hydroxide, you'd be solving for H+. So the first thing we had to do in this one is take that pH, subtract it from 14 to get our pOH, then we can plug that in to our equation to solve for hydroxide. Alright, last practice problem, and then this video will be done. Alright, what mass of sodium hydroxide should be added to 300 milliliters of water to create a solution with a pH of 11.5? Alright, this one seems super complicated, but again, it's just a matter of taking knowledge that you already have and applying it to a new situation here. My camera keeps coming out of focus. There we go. Alright. So let's consider what we have here. We're solving for mass of sodium hydroxide. We're given the pH and we're given a volume. So what that should tell us is that we're going to need to calculate the molarity of that sodium hydroxide. So what we're actually going to be solving for first, or trying to solve for first, is the molarity of that NaOH. We can take molarity of something and volume of it, of that solution, and figure out mass relatively simply, but you just have to understand the process, the steps that go through it. The steps individually are simple, it's just figuring out what those steps are. So let's start with what we're given here. pH is 11.5. So we know pH is 11.5. All right. Ultimately, we want to solve for the mass of a base, and sodium hydroxide is a strong base. So that should tell you that we don't need pH, we need pOH, because we can't solve for hydroxide concentration or the concentration of base without pOH. So our first step would be take that pH and use it to find our pOH, which is pretty simple. Again, 14 minus the pH. So our pOH, 14 minus 11.5, 2.5, our pOH. All right. Well, now that we have the pOH, we can use it to solve for the concentration of our base. We know that concentration of a base, in this case sodium hydroxide, is equal to 10 to the negative pOH, right? So that's equal to 10 to the negative 2.5. All right, well, let's get out our calculator. Second log negative 2.5 and enter. We don't have to do a scientific notation on this one. That's nice. So 0.003. If you put 0.0032, that's fine, but I'm going to leave it at 0.003. That is our molarity of our base, molar sodium hydroxide. All right. Well, we have a molarity now, and actually the rest of this problem is a molarity calculation problem, like we did in the last unit. So we have a molarity, we have a volume, and we're trying to figure out the mass that's in that volume. So this is kind of like this. This is the second method of solving solution problems. So 0.33 molar, we're going to take that and we're going to set it up as a fraction. That fraction is 0.003 moles over 1 liter. This should start sounding familiar, right? We're going to set it equal to a second fraction because we don't have 1 liter of solution. We have 300 milliliters or 0.3 liters of solution. So we need to know how many moles are in that. Cross multiply and divide here. So we get 1x is equal to 0.0009. Not very many moles. And you're thinking, yay, we got it. That's the moles of NaOH. We're done. Oh no, oh no. Because the question says, what is the mass? So we now have to take these moles and, that's right, train tracks, convert it to grams. So 0.009 moles NaOH, converting it to grams. So molar mass of NaOH is 40, I believe. It is 40. 40 grams per 1 mole NaOH. So the very, very last thing we do, number of moles times the molar mass, will give us our final answer. So 0.009 times 40, 0.36 grams NaOH. That's it. Super duper simple. I joke on this because this is about as complicated as I can make these problems. Like, this is literally the most complicated I could have made this problem. Not only am I making you use, pH, pOH, 2 different equations for those, you're also having to use knowledge from previous unit on how to take molarity of a solution and figure out how many grams are in that solution. So this is really, really complicated. Most of your problems won't be this complicated. But I like throwing this in here because this is literally the hardest problem I could give you. And if we break it down stepwise, you'll see that it's really not that difficult. It's just knowing the order to do those steps in. And if you just use a little bit of thinking and slow your brain down just a little bit, I think you'll find that the process is pretty straightforward. Alright, there's your practice problems. If you want, go back and watch this again. I know I went kind of fast, but there you go. Alright, until the next one, see ya.